All right, hello, welcome back, everyone. Today I'm going to be talking about the operations of algebraic vectors in 3-space. So we've already talked about algebraic vectors in 2-space, and if you've already seen that lesson, then that'll make this lesson a whole lot easier. So make sure that you see that lesson before you see this lesson, because it'll make this lesson make a whole lot more sense. I'm going to walk through this lesson assuming you've already seen the last lesson. So here it asks us to draw the position vectors 7, -11, 13, and 4, -7, 25, and then write them in standard form. So at this point, I would hope we're already familiar with I and j, and that I is our unit vector for x, j is our unit vector for y, and k is the only new one, and that's, as you might have guessed, it's our unit vector to represent a unit of z. Okay, so I'm going to draw these, although that's probably not really the most important part of today. I will still attempt to draw them. Actually, I don't know if there's space to draw them, but I will do my best. Let's see if there's space to draw these. Okay, so A is 7. Y is -11. So that'd be down. That would be 11 to the opposite direction. Yeah, unfortunately, it says draw the vectors, but we can't really draw these, unfortunately, especially because the y values here are -11 and -7, which would actually mean that they would go past here somewhere. We'd have to have more spaces here, so that's not actually going to work. However, we can do them algebraically just as well, and that's general, not just with this stuff, but in general. And I feel that graphing is just a very not the best technique, because it doesn't always show things clearly. It's difficult to do, whereas algebra is something that we know how to do. We can do a lot more easily and get much more accurate results from. So I'm kind of glad we can't graph this. So let's continue on. Let's ignore where it says to draw them and just focus on writing our position vectors properly. So for OA, we have 7, -11, and 13, which means that we have 7i plus, not plus, minus 11j plus 13k. Then we have OB, 4, -7, 25. For I plus 25k. All right, there we go. Now it's asking us to find the magnitude of OA, and same method as before, right? We're going to use Pythagoras' theorem, but with all 3 dimensions into account to figure it out. So we're going to have root of 7 squared plus -11 squared plus 13 squared. And that's going to be what? That's going to be root 49 plus 121 plus 169, which is going to be about 18.41. So there we have it. And same thing for this one, right? Same method. We're going to use Pythagoras' theorem in order to find out the magnitude of OB. So here we're going to get 16 plus 49 plus 625, which is going to be bigger. It's going to be about 26.27 once we punch that in the calculator. And so there we go. There we have it. Okay, now it's having us do the same steps that they had us do for 2-space. They're basically having us add up A and B, or adding up OA and OB, and figuring out what that is, and then finding the magnitude of what we find. So let's go ahead and do that. So just a reminder, we're just going to add 7i minus 11j plus 13k plus 4i minus 7j plus 25k. Let's put our vector symbols. I know it takes a while and it's a bit tedious sometimes to always put the vector symbols, but it is always good to do that, to indicate to your teacher that it is a vector and not something else. Although if they do say I, J, and K, they probably should figure that that's what that is. They're probably familiar with the topic, so that's good. And this would be equal to 11i minus 18j plus 38k. And then if we want to find the magnitude, we're just going to square root the sum of the squares. Like that. That's going to be equal to 121 plus 324 plus, I don't know that one, 38 squared. Okay, 1444. There we go. And that's equal to 43.46. There we go. There we have it. And then now the same thing, we're going to take those vectors we found, we're going to subtract them, and then we're going to plug the resultant into our Pythagoras' theorem equation. So same thing again, pretty straightforward. There we go. So here we're going to have 7i minus 11j plus 13k minus 4i plus 7j minus 25k, because remember we got to distribute that negative through all three is important. So that's going to give us 3i minus 4j minus 12k, and we're going to end up with 3 squared minus 4 squared plus negative 12 squared, which is equal to root 9 plus 16 plus 144, which is equal to root 169, which is convenient because that gives us exactly 13, so that's perfect. Good. All right, and then over here, we're going to have b subtract a, which actually means we're going to get the same thing backwards, as you can imagine. So we could even just write here that's going to be backwards. So it'll be negative 3i instead of positive 3i plus 4j plus 12k. Or, I mean, we could do it out, but given that we've already done this work, we might as well just repeat that, right? And then same thing here in terms of the our magnitude. Same thing. It's going to be the exact same thing, because as soon as we square those numbers, even though they might be negative versions of one another, as soon as we square them and take the square root, it's going to end up being the same resultant. Okay, now let's try this example here where they give us some other values and we need to do a distribution, and then we need to find the magnitude of that as well. So let's do it. Okay, so here we have 2 times x, so that's going to be negative 3i plus 4j minus 5k minus 4 times negative 4i plus 2j plus 6k is equal to negative 6i plus 8j minus 10k plus 16i minus 8j minus 24k, which is equal to 10i plus 0j minus 34k. Okay? Or in this case, we could even just leave out the j. I prefer to write 0j to indicate that I didn't forget about it. I didn't forget that j was there, but there is none of it. But either way is good. And then I'm going to do the same thing over here. I'm going to say this is the square root of 10 squared plus 0 squared plus negative 34 squared, which is going to be equal to 100 plus 0 plus 1156, which is equal to 35.44. And so there we have it. That's how we can use the operations of vectors in 3 space. Very similar to operations of vectors in 2 space, just a few more steps because we have that extra variable in there, right? We have z, right, which equates to k when we talk about the unit vector. And there we have it. That's it. We'll see everyone for the next lesson.